Okay, now let's actually talk about functions in this video. So let's start off with the definition. The definition is as follows. A function is a relation, like we've been talking about, a correspondence between inputs and outputs, where each input, or I guess domain value, corresponds to only one output, or range value. So let's go back and look at all the different relationships we looked at in the previous videos. The first thing that we looked at was this kidney bean blob diagram, which took the inputs from the domain 0, 2, 1/2, negative 3, 5, and mapped them over somehow by some rule over to the outputs we have on the right side, our range. And we had represented that as a collection of ordered pairs. So how can we find out whether or not this is a function just by looking at our ordered pairs or the kidney bean blob diagram? Well, the definition says specifically that each input has to correspond to only one output. Now, if I take a look at my inputs here, I want to specifically notice the input 1/2, which has two arrows or two connecting correspondence lines coming out of it. And that means that this particular input, 1/2, corresponds with multiple outputs. So this is the input 1/2 has more, let's make sure that looks like a word, more than one possible output. So relation A is not a function. So that's what you're looking for. You're actually looking for repeated x values that have different y values. So no repeated x values with different y values. That's what you're looking for when you want to say something is not a function. Okay. Now, over here on relation B, we have something similar going on, but in this particular case, the only time that we're doubling up here is on 4. Now, is that going to be a problem for us? Well, actually, no. This is okay for functions. That is to say, there is no x value with multiple y values. That's not what this is. This is a y value with multiple x values. This does not violate the definition of function. So we're okay there. This is outputs with multiple inputs is not the same thing as inputs with multiple outputs. So let's write that down. Note: outputs with, or from, I should say, outputs from multiple inputs single outputs from multiple inputs is okay. Single inputs with multiple outputs is not a function. So, in this particular case, relation B is a function. Okay. Now, what we're going to talk about is some standard issue stuff when it comes to this class and in the future. We're going to talk about what's called the vertical line test, or the VLT. The vertical line test says that for a graph of any relation, if any vertical line intersects the graph more than once, the relation is not a function. Not a function. So if it intersects, let me make my highlighter bigger here. If it intersects the graph more than once, then it's not a function. So what we're going to do here is we're simply going to draw some vertical lines. So let me draw a vertical line. Do my best to make that vertical. And I'm just going to drag this across my relationship. And the first point it hits, by the way, this is relationship A from the first video in this section. I'm kind of recycling my graphs here. So as I drag this from left to right, or right to left, anywhere, I hit my first point down there at negative 3, 3. But there's no other point anywhere on that vertical line, so that only intersects the graph once. And then I come over to my next point, boom. And that only hits the point 0, negative 3. But then I get here. This fails the vertical line test. And so, again, relation A is not a function. Now, we already knew that because these are the exact ordered pairs that we're talking about right here. This is relationship A. This is just the graph of A. So I already knew that that was going to happen. But what you can see is these ordered pairs, 1/2, comma 8 and 1/2, comma 4, have that common x value with different y values. Okay, let's keep going. Let's draw another vertical line here. Now, don't forget we've already worked on relationship B here a couple of times, but let's go from left to right. There's the first point we hit. That's okay. There's no other point. Then we hit our next point at 0, 8. That's okay. No other point. And then we get to 1/2, negative 3. No other point there. And then 2, 6. And then 5, 4. And so this passes the vertical line test at all possible points. So, as we saw before, relation B is a function because it passes the vertical line test. Okay. This next one is going to fail miserably in just about everywhere. So what we have here is our vertical line, and as soon as we get into the middle of our ellipse there, we can see this fails the VLT. Fail. Not a function. It looks like we're okay here, though. If I move from left to right, at no time will there be more than one point on that graph intersecting my red line. So this is going to pass the VLT, which means that f is a function. And then our last little graph here, it's kind of weird guy. If we move from left to right here, we're only intersecting the graph at one point. And in fact, over here at these lone points, they're only going to intersect once. And so if I were to draw that, I guess this would be the point of intersection. This would be the point of intersection. And so on and so forth. So this passes the VLT, which means G is a function. So that's how you use the vertical line test. But what is the vertical line test doing? What does it mean? Why does the vertical line test work? We know how it works. You just draw a vertical line everywhere and see if it touches the graph more than once. Well, if you have a curve, whatever it looks like, on your XY axis, and you draw a vertical line anywhere, what does that vertical line represent? You guys remember? Well, the equation of a vertical line is what? Do you guys know? It's of the form x equals c. So this is the line x equals -1. If it was straight. There we go. If I duplicate it here, I'll bring this over here. Something like that. 1, 2, 3, 4, 5. And over here, this is x equals 5. So there's a couple of vertical lines. So the equation of a vertical line is x equals c. So each vertical line represents an x value from the domain. Now, when that vertical line, say at x equals -1, only intersects the graph at one spot, then what we have is, when we draw a horizontal line, it only corresponds to one y value. Maybe I should shorten this up. So when x equals 1, this is the y value that goes with it. So when a vertical line intersects the graph only once, that particular x value has only one y value associated with it, corresponding to it. But over here, when the vertical line intersects more than one time, then that corresponds to multiple y values on the y-axis. So this might be, let's see, that's 2, 3, 4, like 4.3, 5.7, something like that. When a vertical line intersects the graph more than once, that particular x value corresponds to more than one y value. Thus, it's not a function. Whereas up here we have is a function. And that's the long and short of it, folks. All right. Take a look at some of that guided practice.